we are going to take a step backwards. We talked about parallel lines and transversals, what relationships exist, which are congruent, which sum to 180, which are supplementary, etc. But I realize when we get to a larger grid like the one that you see on your screen right now, this could be a little challenging just to identify what would alternate versus same side be. Where are the interior and exterior angles? What does a transversal mean? So I'm going to just backtrack, go through the topics that you see on your screen right now, identify these angles, make sure we can see where they are in the grid, and then we can apply what we kind of go back with here and understand to the previous video where we discuss parallel lines and prove why they work, etc. Okay, so I'm going to run down these topics here for you. The first topic, of course, is just the idea of a transversal. I believe I misspoke in the last video. The last video, I think I used the words, a transversal is a line that cuts through two parallel lines, when in actuality, a transversal is a line that cuts through any pair of lines. And the angle relationships we discussed in our last video are true when the lines that they cut happen to be parallel. But the word transversal just means a line that intersects two lines. And when that line intersects two lines, a host of angle names come out that we're going to talk about right now. So let's start with the first group. So I'm going to highlight a transversal here for you now. We know these lines here going horizontally are parallel because they have the extra arrow here. And then because they're parallel, or because they're two lines rather, excuse me, we have a transversal here that I'm highlighting in green. This transversal is cutting these two lines. So what I want to do now is discuss, based on this transversal, the relationship between some of these angle names. Now, before I do that though, I also want to highlight the parallel lines we're discussing so you can get a sense for where we're talking relatively, because now if we have two sets of parallel lines intersecting, there are four potential transversals and two sets of parallel lines, which means we're using the words interior and exterior for different cases. We're using alternate and same side for different cases. Not every single angle will fit an exterior or interior for the other transversals. So we're going to discuss that now. We're using this as our first transversal and these as our parallel lines. So corresponding angles, when you have a transversal cutting any lines, are simply two angles in the same position in the groups of four that are cut. Whenever a transversal cuts a line, it creates four possible angle measures. For our purpose, we'll call them top left, top right, bottom left, bottom right. Whether the lines are parallel or not, we still have a top left angle, etc. When we're talking corresponding, on the transversal, we're talking about two angles in the same position. Angle 1 is top left, angle 5 is top left. So we would say those angles correspond to each other. So corresponding, the idea of a corresponding just means in the same position. Imagine picking up the group of four and overlaying it. When lines are parallel, it's really easy to see this because they look the same. Pick this group of four up, land on top. The two angles in the same spot, they correspond to each other. All right, now let's talk about interior versus exterior. I know we're going out of order with what order the names come in, but I want to focus on the parallel lines first because I like to use a sports analogy kind of with this. Imagine the parallel lines form the boundary of a field, whatever field you like to play on, soccer, lacrosse, football, etc. If these are our boundaries, then anything inside the boundaries we would want to call interior. So what kind of angles would that be? Well, angle 3 is inside the boundaries. That's an interior angle. Angle 6 is inside the boundaries. That's an interior angle. On the other hand, we would say that the angles outside, out of bounds, like 2, like 8, like 7, like 1, all of those angles are out of bounds. They are outside of the boundaries. If you were a football player, they are on the bench. They're holding their helmet on the sideline. They're outside. These are our exterior angles. So inside the boundaries are interior. Outside the boundaries are exterior. Okay. So we have the transversal here. Alternate versus same side means either the angles are on left and right, for this case because this is going up and down, or they're on the same side of the transversal. So for instance, angle 1 and angle 8, they are on alternate sides of the transversal. One angle's on the left, the other one's on the right. If this was a transversal going horizontally, you'd say top versus bottom. Angle 5 and angle 4 are also alternate because they're on opposite sides. Same side angles would be angles on the same side. So since this is going vertically, it's pretty easy to see that angle 1 is on the left, so is angle 7. Angle 4 is on the right, so is angle 6. And if you Let's talk about the relationship that exists between angle, let's go with 4 and 5. Well, they're not corresponding because 4 and 8 are corresponding and 5 and 1 are corresponding. So that's out. So let's talk about where they are with respect to the transversal and then see if they have a relationship because they're within the lines. 4 and 5 are on alternate sides of the transversal, so we would call these alternate. And then the boundary is in bounds here for these parallel lines, so we would call, and they're both in bounds, so we would call these alternate interior angles, 2 words. And you know, based on your other video, when lines are parallel, that alternate interior angles happen to be congruent. Angle 4 and angle 9. So the first thing you want to do when you're trying to name these is you want to identify the transversal. Well, the only line that these both lie on is these two, is this one, rather. Well, once you've identified your transversal, then it's pretty easy to pick out where the parallel lines must be. We'll stick with yellow. These are the parallel lines. So now I want to come up with, well, how do they relate on the transversal that's in blue? They're on opposite sides of it, so they're alternate. Great. What about the parallel lines? Are they inside the boundaries or are they out of bounds? Well, if these are our boundaries here, looks to me like 4 and 9 are both in bounds. They're on the field, so these angles would be alternate interior angles. Well, what happens with angles like angles numbered 1 and angle number 13? Well, surely they must be corresponding because they're in the same group, same position in the group. Maybe, well, no, not maybe at all. The reason why is they're not ever on the same transversal. So let's use the highlighter here. One is either on this transversal going through the 2 lines going horizontally, or it's on a transversal running horizontally through the 2 lines that are vertical. So there's only 2 possible transversals. Angle relationships that we named here only exist with angles that share that transversal. Going diagonally is going to be a big no-no, right? Imagine when you have a grid like this, imagine these are walking along bridges, and that's okay, but trying to go across the ocean maybe, or a big massive hole, I don't know, not safe, right? So this isn't going to work. 1 and 13 will not be corresponding angles. 1 and 16 would not be alternate exterior angles because they're on the outside. You cannot jump diagonally when you're naming these relationships. As a matter of fact, the entire proof section of our unit is going to discuss how do we prove that these angles have to be the same as each other by using the relationship we're discussing now.